DTS-lint is what to look for. The next topic we're going to jump into is classes. And you're probably familiar with using classes in regular JavaScript. TypeScript adds some new concepts on top of what you're used to. There is something new we need to think about in terms of class fields. And TypeScript also introduces the concept of access modifier keywords, which allow us to have control over who can see member data and member functions on instances. So let's go to the notes to the for class basics TS file. So in this example, you can see a couple things. The first is that we're using a new, something I've been calling a heritage clause, right? Extends is the only thing that we can use to describe inheriting from another entity in JavaScript. That you can say class extends base class. TypeScript introduces implements, and that describes a class aligning with a particular interface. So has email, we know this type requires that everything have a name that's a string and an email that's a string. What this means for any class that implements this interface, we have to make sure that these properties that conform to that interface are available and stated up front. So in terms of what this means up here, this is us declaring that these member data fields will exist, and their type is going to be a string. Here, we're stating that we accept two parameters when within our constructor. We accept two parameters, and down here, we're making sure that we pass the things our constructor receives onto the instance, which of course is this within the constructor. We can see right away that this is a lot. This is verbose. Like we have to specify email and name. Those words are here 3 times, right? Once to define the type, once in the constructor signature, and then as we pass from function arguments onto the instance. So TypeScript has a shortcut for this called parameter properties. And we're going to look at that, but at the same time we have to introduce these access modifier keywords. So you'll see these as being one of 3 choices: public, which is what you're used to, right? The only thing we have in JavaScript is public, and public with an underscore, which means shame on you for using that, but it's still public. Protected allows the instance and any instance of a subclass to see it. And private means only that type can see it, only that class. Even a subclass won't be able to see a private method or a private field. So here is an example of these parameter properties. And unfortunately, the auto formatting kind of makes things less than ideal. So the difference here from our previous example, obviously there are a lot of things that are not present, but through adding an access modifier keyword before our constructor's arguments, we can create the equivalent setup to what we had before. In fact, I've even added a little something here, and that is a default value for the second field. So this means I take an argument in my constructor, and a parameter, like a field of the same name, should exist on the instance. And when you receive it in the constructor, you should place it on the instance. And I'm going to convince you of this by taking this exact same example. I'm just going to remove the interface, and I'm going to put it into the TypeScript playground so we can see the JavaScript that it compiles to. And get rid of the interface. So on the right side, I know we're getting a little cut off here, but we can see that if the email is, this is undefined, void 0 is undefined. If the email is undefined, initialize it with the default value, and then we receive name as a function argument, we put it on the instance, same with email. And then this is the comment that was actually in the body of our constructor. And so you can see anything in your constructor that you do custom would happen after all of this mapping has, from parameters to fields has taken place. This is a really nice convenience because it allows us to do this common thing where, we want to pass some stuff into a constructor, get the fields. It makes it a lot less verbose. Note that if we were to make this protected, which means the outside world, when interacting with an instance of param prop contact, it wouldn't be able to see this field. So we still can receive it as an argument, but you're not going to be able to access it from the outside. Just passing in some nonsense fields here. So down here, nonsense values rather. Down here you can see we only have access to name, whereas before we have access to both. So that's the difference in making it public or protected. And you'll note that another consequence of me making it protected was I get an error up here saying the class incorrectly implements the interface has email. Can anyone make a guess as to why this error is happening? Clearly the field is there, but why might TypeScript be objecting?
Email's not visible.
Email's not visible. You expect the instance of this class to be a has email, meaning you can access name and you can access email. That's what it means to be a has email. So you're not really conforming to an interface unless the things that allow you to conform to it are public and visible from the outside. And now the error goes away. So class fields can have initializers. If you want a param prop initializer, just do the same thing you would do for function arguments, because it is a function argument. That's kind of where it lives, right? So that's the default value for the email field. But if you have properties that are not things that you take in as arguments to a constructor, in this case, age, which you can see up at the top, you can just do the same thing you would do in JavaScript. This effectively is a default value if it is not in some way set like within the constructor here. So if in here I were to do like age equals 35, now like this will never come into play. It is only initialized with that if it has not yet been initialized up until that point. Where do we see evidence of that? It's basically going to turn into this right here. If it's undefined, initialize it. Did you have a question, Chase?
Yeah, does it infer the type if you give it a default?
Yes, because it's kind of same rules as a variable, right? Like you're giving it its initial value, and so it will do the best it can to make a reasonable guess at the type. Now, the one thing you'd want to be careful of is if this could be a string or could be a number, and you initialize it to a number, you're going to have to specify that, like you'll deliberately widen the type to include the possibility of a string. So it'll make its usual guess, and rightly so. I can take that away, and it'll still be number. There's one other thing that kind of fits into access modifier keywords, although it's not really about access in terms of visibility. You could also do read-only. And that, from a type checking perspective, will yell at you for attempted sites where you're trying to write to this value. Don't fool yourself, though, because there may be JavaScript consumers of this library, and this does nothing at all in terms of actually preventing writes to this value. It is just like a linting thing for people using type information. So I'll use this once in a while, but just be advised that like not everyone uses type information, and this is just making a check, right? In this situation, we're just providing an initializer by kind of another means. We could just as easily move this up as a property initializer, but I'm pointing out that we can do it in either place. Additionally, if my TypeScript settings are correct here, and they are, you'll note that we're getting yelled at here. It's ignore this first message. We just see that a lot because we have a lot of classes and things that are never read, right? Because it's just a page of examples. This error message is interesting. Password has no initializer, and it's not definitely assigned in the constructor. So what we're seeing here is we've stated that password is a string. And for any downstream code, any methods that might be able to access this private field, if they try to access password, they expect to get a string back. And currently, that's not going to happen. Even if we had a condition here where if we said like, if phone is greater than 0, initialize this, we'll still get an error because through analyzing the various paths we could take through our constructor, one or more have been identified where we would not end up setting password up with a value. There are a couple ways we could handle this. Well, one way would be to decide that this is a problem. We just should always initialize password. The other way would be to add add the possibility that this is undefined. And now anyone who attempts to access password, they'll get string or undefined. They'll have to use one of those guards that we showed an example of before. You know, if this dot password, and then within that block, password will be a string. So that's one thing we could do. Here's another thing we could do. We could use a new operator here, and this is one we'd want to use if we really know that phone number, like it's guaranteed to be greater than 0. Basically, like you know for a fact that you're always going to go down this branch and it's going to be okay. Or maybe every time you instantiate this class, you call a method on it to do some asynchronous setup, right? Like if we did this. Right, an asynchronous init function, there's no way to make a constructor asynchronous. Sorry, I keep saving and things auto-format. There's no way to make something asynchronous, but perhaps we just know that wherever we use this, right after we construct it, we call init, and then everything downstream should be able to depend on password being there. In this case, we would use something called the definite assignment operator, and it is an exclamation mark. What this is saying is, trust me, TypeScript, I'm taking responsibility for making sure that this field gets initialized properly. So this is an area where I want you to let me handle this and don't cause an error at this point in the code. So where might another useful place for this kind of thing be? Raise your hand if you've used Angular, React, Ember, Polymer, or Vue. Awesome. So do you find that you end up directly instantiating components? Like you have a component class. Do you find you're ever calling new component and then rendering it and putting that element in the DOM? Or is the framework handling it for you? Framework handles it for you. So there are often lifecycle hooks where you might be, setting things up, setting up properties. And in an early lifecycle hook, you might take care of putting password in place. And you just know that like, this is the first thing that's going to be called. The framework's doing the constructor stuff. I'll take responsibility. Like, I know there's this little gap very early in the lifecycle where password's not there, but like realistically, I'm not doing anything with that code. And that simplifies downstream stuff where you can just access password and trust that it will be there. Here's another related tip. Let's say that realistically, we don't know if password's going to necessarily be there. Like maybe in the middle of its life cycle, your component might get something, right? And you still want to simplify things a bit. I would do something like this. I would have a value that has the potential to be undefined. And I could do private get password. This is just a ECMAScript 5 getter, ES5 getter. It's worked for a long time, works natively in IE 11 and 10. If the password value doesn't exist, we'll create it lazily and then return it. And we can say this is definitely a string. The end result is here we have a property that's a string, and we can access password wherever we need it. It's lazily created the first time we ask for it, right? And then it's cached on the instance. And so we could repeatedly go ahead and keep asking for it. We still instantiate it once. But this is another trick for things that may start out as undefined, and you can kind of create a lazily instantiated value like this. Questions? Cool. This should be mostly regular JavaScript stuff, especially that. It's kind of underutilized, but getters have been around for a while. This, kind of feel obligated to show you this, although I don't find that I use it all that often. Abstract classes. Abstract classes cannot be instantiated directly. They just serve as base classes. So unlike an interface, which also can't be instantiated, abstract classes can have implementations, right? In this case, I have a constructor with some param properties. So name and email will be there. It's serving as a base class. But I also have an abstract method here, and that must be implemented by any subclass. So I think of this as sort of half class, half interface. And this lets us pass around. We can still refer to things by their abstract base class, but concrete implementations may look very, very different. All you have to do here is make the class abstract, and then you can make both fields and methods abstract as well. And subclasses are required to implement those with a compatible access modifier. Like you could take something protected. I wonder if you can even do that. Yep. No, looks like that they have fixed this here. So got to make things public, because it would be kind of strange to have abstract things that are private, like how you don't really have visibility into subclasses in that way. So here's an example of an implementation, and you can see if we were to remove send email, it's going to tell us non-abstract class concrete contact does not implement inherited abstract member send email. So we have not met all of the requirements we need to meet.